Feeling my way through the dark.
Hi guys, welcome to my first podcast. Very excited about doing this, but also a little bit nervous that I'm going to make a fool of myself, so please don't laugh at me. Today we're going to be learning about looking at pedigrees and analysing them to determine the mode of inheritance. So what I mean by that is if it's recessive or dominant, but also if it's autosomal or sex-linked. So we're going to be looking at that today. You notice here that this is a pedigree. I'm sure you've seen these before. So this particular pedigree is showing the inheritance of a trait. So we don't know what trait it is, but one particular trait through a family over a number of generations. So you can see here that it's showing 4 generations. You're probably also noticing there's some circles and squares. Well, the circles is a female, and in this particular case up here, this is a female with the condition, and the squares are males. So if they're not coloured in, it means they don't have the condition. And as I said before, this particular pedigree shows 4 generations. So how do we analyse a pedigree? Well, there's a number of ways, but in general the rules are the same. So analysing them, as I said before, you are determining the mode of inheritance. So like I said before, dominant or recessive. And remember, I've said in class a number of times the definition for dominant, or the most correct definition, is that it's a trait that is exhibited in a heterozygote. And also if the gene that we're looking at is located on an autosome. So remember, humans have 22 pairs of autosomes or a sex chromosome. So for females, we obviously have 2 X chromosomes, but for a male, they have an X or a Y. So the conditions, if they're sex-linked, so carried on a sex chromosome, can either be X-linked, so carried on the X chromosome, or Y-linked, carried on the Y chromosome. And obviously you would have seen with the pedigree before, it doesn't show too many individuals, so it's not always providing the most conclusive evidence. It's just a good idea to remember that. And obviously doing a test cross with humans is not often possible. So have a think why we don't do test cross with humans and often just look at a pedigree instead. So these are the rules for determining the mode of inheritance. So like I said before, whether it's recessive or dominant, and whether it's autosomal or sex-linked. So these rules we're going to go through. They look quite big, but it's not going to take too long to remember all these rules. So let's have a go. First of all, we're going to look at autosomal dominant. So those traits that are carried on an autosome. So it could be any of those 22 pairs, maybe 1, 4, 6, etc. And it's a dominant trait. So an idealized pattern would show that both males and females are affected, usually in equal numbers. All infected individuals have at least one affected parent, and transmission can be from either the mum or the dad. So here we've got one here. So this is showing autosomal dominant. First of all, you notice obviously circles, squares. There are 4 females in this example that have the condition, and there are 3 males. So that is roughly in equal proportions. The other thing that I've noticed, and you've probably noticed too, is that it's actually present in all generations. Can you see that? So all 4 generations, there's at least one individual with the condition. And another thing is that all the infected individuals have at least one parent that is infected. So if we look at generation 2, number 2, this female here, her mum was also affected. And if we look at this boy here, his mum was also affected. So it's present in all generations. That is a telltale sign that we're looking at a dominant trait. When we look at autosomal recessive, what we will notice, being autosomal, it means that both males and females need to be equally or roughly equally affected. But the difference between recessive and dominant is that in a recessive pedigree, you're going to notice that it skips a generation. So two unaffected parents can actually have an affected child. And you're probably thinking, how is that possible? And you need to go back to those terms, homozygous and heterozygous. And when we look at complete dominance, so the example I always go through, I know in class, is tongue rolling. If there's a child that can't roll their tongue, but their parents can, that must mean that they're heterozygous because they're both given that recessive trait to that child. So here is a pedigree showing that. So you can see here, automatically, it skipped a generation. So that first generation there, it wasn't present, but then in the subsequent generations it is. And then also, because we said it's autosomal, let's look at how many females and males are affected. So we've got 1, 2, 3 females here. 1, 2, 3, 4, 5, 6. So again, the numbers aren't roughly equal, but both sexes appear to be affected. So we can sort of assume that it's going to be autosomal. Another thing you might notice here, which doesn't really appear too much, but this kind of looks a bit different to how all the others appear, right? They're a bit different to these two boys here. Have a guess what that means when we've got this linked, these two linked a little bit differently. It actually means that they're fraternal twins. So if you said that, well done. Sometimes they'll show different ways of showing a pedigree. For instance, they might have an individual with a cross through it, and that means that they've died. There's many different ways of showing a pedigree, but for your exam, often they just show it in its simplest form. So they're the rules that we looked for. Now we're going to go into sex linkage. So we focus in Year 12 just on X-linked conditions. As you would have probably noticed when you've seen, the chromosomes all lined up in a karyotype, the X chromosomes are quite a bit larger than a Y chromosome. So that would then infer that a Y chromosome doesn't carry too many traits or genes. So there's only a few genes that are carried on the Y chromosome, but those genes are obviously what makes a male a male. So we're just going to focus today on X-linked conditions, so those carried on the X chromosome. Now, because they're X-linked, you're going to see a difference with the amount of females and males affected. All right, so when you see that a male with the trait, he's going to pass it on to all of his daughters, but none of his sons. So if you see that appear, that tells you that it's X-linked. A female with the trait may pass it on to both her daughters and sons. So, and because it's dominant, you're going to see it in every generation, or roughly in every generation. So let's have a look. Here we go. So this is our pedigree, and you'll notice that it's in every generation here, right? So in each of the 4 generations. And remember, it said before that an affected dad, so this one here, gives it to all his daughters. So look at here, 1, 2, 3, right? And again here, this dad has given it to his daughters, 1, 2. So that's telling us it's X-linked dominant. Looking at X-linked recessive, so you would have probably done this one a little bit in class. Examples are colour blindness, for example. All the sons of a female with the trait are affected. All the daughters of a male with the trait will be carriers, but will show the trait, sorry. So if we look at that, here we go. I'll point out what these mean in a second, but again, because it's recessive, see how it's skipped generations? All right, apart from that generation there, but it's skipping some generations here. And that must mean, if this is a recessive trait, that must mean that both these parents are heterozygous. All right, so they're saying here that that mum is a carrier and that mum is a carrier. But I just wanted to correct myself actually, because I said both parents are carriers, but this father technically can't be characterised as a carrier Do you know why? Remember in class we were saying that when you looked at X-linked conditions, you could only call the mum heterozygous or homozygous, but a dad is hemizygous because he only carries one X chromosome. So that's why technically we can't call this male or this male a carrier. So hopefully you remember some of those rules. And what we'll do, we'll have a little practice with this one. So I want you to give this one a go and determine what type of inheritance it is. Okay, so hopefully you've seen there are 1, 2, 3, 4 males affected by this condition and no females in this case. And it's also skipped some generations. So I'm going to say that this condition must be recessive, and because it hasn't affected any females, I'm going to say it's X-linked. So well done if you got that right. Now this one, it's showing that both males and females are affected in roughly equal proportions, and it's present in every generation. So have a think about what that means. If you said that this condition must be autosomal dominant, then well done. Give yourself a clap. So hopefully today you've learned a little bit about pedigree analysis. We'll talk about it more in class, and I'll also give you some more examples of exam questions.